Hi everyone, thank you so much for making the time to join me for this session. I'm really honored to be able to be speaking to you all today at the first day of DaprCon 2021. Now, my name is Cecil Philip and I'm a senior cloud advocate at Microsoft. But what's more important is that I'm a huge fan of how Dapper can make microservice development so much easier. Now, if you recall from the previous session, you saw Mark speaking with a few customers, and they were talking about how Dapper can give them the flexibility that they need to be able to solve some of the concerns they have inside of their infrastructure. Well, in this particular session, I want to take a little bit of a step back, and instead we're going to focus on what that hello world getting started experience feels like inside of Dapper. So I want to show you how to get the Dapper tools and the CLI installed on your machine. We're going to see how you could quickly Dapperize an application that you probably already have on your hard drive right now. Then we'll explore some of the different building blocks that are available out of the box with Dapper. And then also, I want to show you how you can combine tools like Docker Compose and Visual Studio Code to create a really interesting local development experience as you're diving into the world of Dapper. So hopefully that sounds fun because, well, that's what we're going to do. So as folks are starting to explore this world of distributed systems, one of the things that you're going to eventually run to is something that I like to call the microservice matrix. And if you've ever heard that from anyone else before, just know that they got it from me, okay? But inside of the world of distributed systems and microservices, there's just so many options for tools that will help you achieve anything that you want to do inside of your application. So if you think about it, if I wanted to do something like service discovery, for example, I might have multiple instances of multiple services, and I need to know what services are available, where are they, what's their health status, what path do I need to take to get there? And there's so many options, like I mentioned, for you to be able to solve that particular problem. You might also have the concern of doing, key value stores and state storage for your different components, right? We have tons of options for that as well. Some other things you might want to do include publish subscribe. Maybe I want to do secrets management, centralized configuration, observability. There's tons of things, right? And each of them have a ton of different options for folks to choose from. Now, the problem with having so many different options is that, well, now we have to take the time to really understand which one of these options are going to work best for us. And, as you have more things that you want to do, that matrix is going to become a lot more complicated. We're going to need to figure out how these components can play together. But also, we're going to need to figure out, well, do they support the operating systems that we're building and deploying on? Do they support the programming languages and the runtimes we want to work with? Do they have SDKs and APIs that we could use to integrate more deeply into our app? What about later on if we decide, hey, well, I don't want to use this anymore and I want to swap it out for something else? Well, how easy is it going to be for me to do that? Like, how much technical debt am I going to have to dig through to be able to switch out this component? And is that work even worth it at the end of the day? So for me, this is where Dapper really shines. Dapper provides a portable, lightweight, event-driven runtime that abstracts some of those common use cases, some of those common tasks that a lot of microservice developers, have to go through today. But for me, the main thing that Dapper gives me is the ability to focus, right? I get the time to focus on the things that really matter and bring value to the business. And in my case, it's usually around creating features and functionality and solving issues that our customers really care about, and not necessarily spending the time to worry about the infrastructure. So as the team for Dapper went down this path to kind of achieve some of these goals, what it ended up doing was creating a programming language agnostic, host agnostic runtime that almost anyone can play in. So regardless of whatever your development environment looks like, you should be able to plug into Dapper and use the tools that you're familiar with in the environment that you're familiar with as well. Now, another thing to know about Dapper is that it is also open source and is very extensible. So if for whatever reason there's a component or there's a feature that's missing, then you could very easily contribute that back to the core product, and now we'll all be the better for it, which I think is amazing. Now, if you recall, I mentioned that Dapper provides us a set of abstractions. And the way it shows us or provides us these abstractions is through a concept called building blocks. And each building block provides a particular task or particular set of functionality that microservice developers might want to use. So if you take a look at the slide, you can see here that we have building blocks that represent things like service-to-service invocation or service discovery. We have state management, publish subscribe when we want to publish messages to a topic. There's even triggers and bindings for that reactive style programming model if you're interested in that. There's actors, observability, application secrets, and tons more. But one of the important things that I want you to recognize here is that all of these abstractions are exposed to you via HTTP and gRPC. So that means that as long as the programming languages that you use support any of these types of protocols, then you'll be able to plug into the world of Dapper without any concerns at all. Another thing that I think is really important to point out, even though Dapper has all these different building blocks, this is not an all or nothing type of approach. You can pick and choose the different components and building blocks based on whatever makes sense. So that means that I could choose to use just the service discovery or the state management building block and not the rest. Or maybe I want to use all of them, or maybe I don't want to use any of them at all, right? The choice is completely up to you. Again, Dapper gives you the choice to use the things that make sense for the application that you're building. Now, the reason I keep repeating this is because I think it's really interesting for all types of applications and not just distributed microservice-ly type applications as well. So if you think about things like legacy apps, maybe I have an older application that we might want to start modernizing. Well, Dapper could be the path that helps plug these two worlds together. So as I'm continuing on one side to develop these very lightweight and efficient services, my legacy application can still plug into that world, and all it has to do is go through Dapper. Now, why don't we take a moment and dive into our first demo, and I can show you exactly what it takes to get started using Dapper. Now, before we really start diving into Dapper, the first thing I want to do is show you this web API that's been built with Python and Fast API. As you can see here, there's really not too much happening inside of this API. But I do want to show you what it looks like before we start Dapperizing. Now, I'm going to start running this in a command line. And what I'm going to do is start executing some requests against this API. Now, I'm going to use the Rust client extension for Visual Studio Code. But if you feel like, you could use anything like curl or whatever other client that makes you comfortable. Now, I'm going to set my host to localhost 8000. I'm going to execute the requests. And as you can see here, status okay, right? Everything looks great. If I come down here and I execute this next method, I'm going to change this query string. I'm going to say, hello, DaprCon. Oh, we can see that everything looks just fine. So let's go ahead and stop this. And now what I want to do is add a little bit of Dapper. Now, if I come back to my command line, notice if I type Dapper, it says command not found. So I don't have the Dapper CLI or any of the tools currently installed on my machine. I think the next thing that we should do now is just to head over to the documentation, because I believe every great open source project begins with great documentation. Now I'm going to click on that Get It Started link. I'll head over to install Dapper CLI. And here you'll see the different instructions based on the operating system that you're using. Now I'm using Mac OS, so I'm going to look for the instructions for Homebrew, and I'm going to copy those because Homebrew is what I prefer to use when I install stuff. Now if I head back over to Visual Studio Code, I can paste that command I just copied and hit enter. And what Homebrew is going to do is go ahead and pull down that latest version of the Dapper CLI and add it to the path on my terminal. So now if I type Dapper, I should be able to see all the various commands that I can execute. And I can see that really cool ASCII art, so you know we're in business. The next thing I need to do before I actually start running Dapper is I need to initialize it on my system. So I'm going to type in Dapper init on the command line. Now what Dapper is going to do is pull down some default components and set up some configuration that we can start using. If you take a look at the output inside of the terminal, you can see that Dapper pulled down the Dapr D binary, a placement container, a Redis container, and also a Zipkin container. And these have already been configured and are ready for us to use. Now let's go ahead and Dapperize our Python application. One of the available commands for me to use is the Dapr run command. So let's see how we could use that to Dapperize this Python application. Now if I type Dapr run, now if I'm going to run my application with Dapper, I need to give it an ID. So this is what we're going to refer to this application or this service as. So I'm just going to call that API. I got to let Dapper know the port that it's running at. So if you recall, this application runs on port 8000. And the last thing that I need to do is I also have to specify the port that Dapper is going to run at. So Dapper has its own HTTP port. And by default, I like to set that to 3500. Now, I have to tell Dapper the application I want it to run. And if you recall, that's my Python main application. So I'm going to go ahead and run this. And now you're going to see a lot of stuff being spit out to the console. There's a few things I want you to recognize here. One, Dapper has discovered our application running on port 8000. So that means it now knows how to get to it. Also, if we start to scroll up a little bit in the logs, you could see that metrics has been enabled, tracing has also been enabled, and also if I go up a little bit more, it's loaded some of those components that we spoke about earlier. So here you see it's configured the Redis component for both pub sub and also for state storage. So now that that's running, let's get a little bit of space. And let's open up this HTTP request file again. Now I'm going to change this port. And instead of us running on port 8000, I'm going to run on 3500, which is the Dapper port. I'm going to send my requests, and notice my body comes back and my status is still okay. But one thing is a little bit different. And you'll now notice that we have that trace parent HTTP header, and that's been included by Dapper to enable some of those distributed tracing scenarios that it provides for us. Let's see what happens when we hit the next request. Notice that works just fine as well. So with changing no code in my application, we've just Dapperized it and enabled a lot of really interesting features. We'll see how we can really make use of them as we go on in this session. Now, before we move on, there's one more feature I definitely want to show you because I think this is really cool. I want to show you the Dapper dashboard. Now, this dashboard by default is going to run on port 8000. And if I open it up on localhost, you'll see it shows me all of the different Dapper applications that I have running. In our case, it's only our Flask API for now. If I click on this section for components, the dashboard will show me all of the components that have been configured for my Dapper application. So right now we have a pub sub, and we also have a state store. I can go a little bit further and even click on some of these components to get a little bit more information about how they've been configured, how long they've been running for. I can even see that default YAML file that created them. So if you want to quickly inspect what's going on inside of your Dapper apps, definitely check out the Dapper dashboard, and it's included by default with the Dapper CLI. Now let's continue moving forward and take a look at some of the components and building blocks that are available for us inside of Dapper. Now that we have Dapper installed and ready to go on our machines, why don't we take a little bit of a deeper step to get a better understanding of how some of it works. Now, Dapper operates in what's called a sidecar model. So that means that for every instance of every service that makes up our solution, we're going to have an associated instance of that Dapper sidecar process. So here you see I have my app. If I had 10 instances of that, I'd have 10 instances of that Dapper sidecar process running next to them, usually on localhost. And now once the instance of my application and also the sidecar up and running, they can start communicating with each other over those gRPC or HTTP APIs that we mentioned earlier. But my application doesn't really need to be concerned about anything else outside of that environment. Right now, if it needs to get pub sub, if it needs to do state storage, secrets management, or if it even needs to invoke a service on another instance of another service somewhere else within my infrastructure, the only thing it needs to do is to communicate through Dapper. And no, those Dapper sidecars are going to be self-aware, right? They're going to find each other, and they're going to be able to know, well, who's going to be responsible for dealing with this request. So here as an example, you can see that we're going to make a request over to the cart service, and we're going to invoke the method new order. And notice how it's using that very standard HTTP type contract. The same thing that could be said for using state storage, right? I'm going to make a HTTP request over to state, and I want to get the inventory state storage, and I want to retrieve the item 67. Here's an example how you can do publish subscribe, right? Like I can create an HTTP payload using my HTTP client of choice based on the programming language I'm using, and I could send that over to this endpoint to publish a message on the orders topic. And here now also you can see an example of how you can get secrets out of a secret store. So maybe I want to store passwords or API keys or things of that nature. Now at this point you might be wondering, well, okay, I see Dapper can give us these abstractions, but what about the concrete implementations that's implementing these abstractions? And well, that's where Dapper components come into play. And if you remember, as I said earlier, Dapper is very extensible. So for every building block in here, we have tons of different options for concrete implementations for each of those building blocks. So you can see for the state store, we support a variety of different databases like Cosmos DB and Redis and Cassandra. For publish subscribe and pub sub brokers, we have support for service bus, Redis, RabbitMQ. Again, and the list goes on, right? For every Dapper component, there's tons of different options for things that you could make use of. Now, like I mentioned earlier, Dapper is open source. So a lot of the components that Dapper supports today were actually contributed by the community. If you head over to the Dapper organization on GitHub and you go to the components-contrib repo, you'll be able to see tons of different components that you can make use of inside of your applications. Now, I think it's time we dive into another demo and see a more concrete example of how we could start making use of some of these Dapper components inside of a more real-world application. This next demo I want to show you is just a little bit more involved, but I like showing it off because it has a lot of different Dapper components working together to create a complete solution. Now, Contoso Crafts is a storefront that has a list of products that you could choose from, and if you want to, You can click on the info button and get more information about a particular item, or you can even go to the different items that you want and you can add them to the cart. So as you notice here, I can click add to cart. As I'm doing that, that increment button here at the top right side keeps going up. If I click on that shopping cart icon, you'll notice here all the items that I added to the cart. And then when I hit submit, hopefully at some point, someone's going to be able to get my order, process it, and those items will get shipped to my house. Now, even though this looks like a simple application, this is actually made up of 3 different microservices working together through Dapper. The first service is actually the web UI, and this is built with ASP.NET Core Blazor, and its job is really just to display the interface that you're seeing right now. The next one is actually the products API, and that's responsible for giving us all this product information that we're seeing. So everything from where the pictures are, the description, the votes, and even the name of what the product is. And then the last one is the checkout service. And its job is just to listen in the background as new orders are being published to a queue, and it'll process those orders accordingly. Now let's head over to Visual Studio Code and see what this looks like. Inside of the Demo2 folder, I'm going to open the source directory. And here you can see I have 3 separate projects. And like I mentioned, one is the website project, the products API project, and also the checkout processor project. Now, if you're familiar with .NET, you know we have this concept of a CS_proj file. And the CS_proj file is where we list all the dependencies for what we need inside of our applications, like different packages we're going to use and things of that nature. So as you can see here, my products API is making use of MongoDB because that's where a lot of that information is being stored from. The last one I'm going to show you here is the checkout processor. Now, the thing that I want you to notice that's common between all of these different CS_proj files is that there's absolutely no reference to Dapper. So then your question might be, well, how exactly does Dapper get plugged into this application so that these services can talk to each other? Well, that's what I'm going to show you right now. Now, to get all of these services running at the same time inside of my application, I'm actually making use of Docker Compose. And not only is it running my Dapper components and my application, but it's also running the infrastructure pieces. So that includes things like MongoDB, Redis, RabbitMQ, and some other really interesting things. Now, let's take a look at the Docker Compose.Dapper file. Now, if you recall, earlier when we were showing the slides, I mentioned that Dapper runs using what's called a sidecar model. So that means for every instance of your application, you're going to have an instance of the Dapper process running right next to it, preferably on localhost. So here, inside of my Docker Compose file, you can see that I'm specifying some options for that main website service, but also right next to it, I'm also specifying the Dapper sidecar that's going to be attached to it as well. If you look at line 25 through line 35, you'll see I have a command where I'm executing that Dapper D binary. And just like we did with the Dapper CLI, I'm passing in an app ID, an app port, but I'm also passing in some additional information so you can know about the components that I want it to configure for me. As we continue scrolling down inside of this Docker Compose file, you'll see that I have a products API. And just like the website, I have some options here that tell Docker Compose how to build my application into a container. But more importantly, right next to it, I have a products API Dapper sidecar, which has options that are very similar to that website Dapper sidecar that we saw before. As we scroll even further down, you probably guessed it, there's a checkout processor and there's also a checkout processor sidecar. Always try to remember, for every instance of your application, you're going to have an instance of the Dapper sidecar. And your application is going to be communicating with that sidecar to get access to all of those different components and building blocks that we have configured. Let's head over to the web application and see exactly how some of this communication happens. Now, inside of the startup.cs file, you can see here on line 23, I'm configuring an HTTP client to use localhost 3500. Now, this is the address that I'm going to expect that Dapper sidecar process to be running on. So whenever I make a request for some services, that's the endpoint that I'm going to use. Next, let's open the services folder inside of that same project. And you'll see that I have a file called DaprProductService.cs. Inside of this class, I have a method called getProducts on line 30. I'm going to make use of that Dapper HTTP client that we just configured. So I create a new HTTP request message. I give it the path. I add the Dapper app ID as an header. And now I go ahead and make my request. Now, once my sidecar process gets that request, it's going to forward it along to that products API. It's going to process that request, get those results back from MongoDB, and bring it back to me. But my web front end knows nothing about where that product API lives. And this pattern is going to be the same for the state store, pub sub, and a lot of the other components that we use inside of Dapper. Speaking of other components, let's take a look and see how some of the other ones work. I'm going to open up this components folder, and I'm going to look for the product list base. Now inside of here, I should have a method that shows me how to actually add something to the cart. And on line 49, you can see I have that add to cart method that takes the product ID and the title of the thing that I want to add to the cart. Now, similarly to how you saw us interact with service invocation, I'm going to use the Dapper API endpoint that's specific to working with state stores. So you can see here, I'm going to specify v1.0/state. I'm going to give it the name of the state store and the state that I want to retrieve. So in this case, I want to retrieve the cart state. Then I'm going to make sure if my cart is empty or not. I'm going to add items to the cart. And then when I'm done doing whatever business logic I need to execute, at the end, on line 87 and 88, I'm going to make another request using that same endpoint, but this time I'm going to be doing a post request so I could save the state versus retrieving it. Last but not least, let's take a look at our checkout. Now, this could be found under the components folder in the checkout model. Now, I'm just going to scroll down here a little bit to where the code is. And inside of our submit checkout model, again, you're going to see the similar pattern. I'm going to use that Dapper HTTP client. But if you head down to line 75, we're going to serialize that shopping cart content that we want to have published. Then we're going to make a post request over to v1.0/publish/ the name of the pub sub. And then checkout is the name of the topic that we want to publish to. Let's take a look over at the checkout processor and see exactly how it does this. Now, inside of the checkout processor project, I have a controllers folder. And that controllers folder has this class called Dapper controller. So if we take a look through what's going on here, you can see I have two methods. One is the subscribe method, and another one is that /checkout method. What's important here to know is whenever our application stands up and that Dapper sidecar discovers it, the sidecar is going to make a call to our app at the endpoint /Dapper/subscribe. And that's pretty much how it's going to check to see if our application is interested in listening to any topics. In this case, you can see that I want to listen to the topic called checkout. And then any messages that come in from that topic, I want you to pass it to the checkout route. Now, if we scroll down a little bit, that checkout route is assigned to that checkout order method. So once a message arrives, I'm going to deserialize that information that comes back in. And then I'm just going to write out a simple log to say that the order was received. One thing you might notice here that's really special is that that message is being retrieved from the request using cloud events. And cloud events is just the format that Dapper uses by default as it's sending pub sub messages back and forth. Now, really diving into cloud events is a little bit past what we're going to be doing in this session, but I definitely recommend you check it out if you're interested in the standards compliant way of sending and receiving messages through any message broker. Okay, now we've seen how our application code works. How exactly do we configure Dapper? Well, actually, if you recall, let's head back over to our Dapper Docker Compose file. And if I was supposed to open one of these sidecars, remember, every time we invoke Dapr, we're going to pass it a config switch to config.yaml file and also the path to a components folder that has the configuration for all of the components that we want to have used inside of our Dapper applications. Well, that components folder actually exists right here inside of our project. So if I was supposed to open it up, you can see that I have that config file and I also have this folder that has a few components configured. Now, if I click on this config.yaml file, you can see that this has some basic configuration for how we can set up tracing using Zipkin. And I'll show you that a little bit later as we go on. Let's open up this local folder. Now, inside this folder, I have a few different components that are already set up for us. Now if I click on the RabbitMQ pubsub.yaml file, you can see exactly how this component is being configured to be used inside of the pubsub building block inside of Dapper. Looking at this configuration, you can see that we have to specify things like the type of component that this is, the connection information, and then some other options that are very specific to RabbitMQ. Let's take a look at the state store. For state storage, we're actually using Redis. And as you can imagine, it's following a similar format. We have to specify the type. In this case, it's state.redis. And then in the metadata, I have to provide some connection information of how exactly we're going to be able to connect to this instance of Redis. One of the things that you'll notice is a little bit different here is I have the host and port of my Redis service, but I don't have the password that I need to log into it. Instead, I'm making use of something called a secret key reference. And if you remember from the previous slides, secrets are just another building block that we could use inside of Dapper. Not only we could use them inside of our applications, but we could actually use them inside of our configuration files as well. And you can see that we're specifying what secret store we're using on line 16 inside of this file. Now you might be asking, how do I configure secrets? Well, there's a YAML file for that. And inside of that same folder, I'm actually using local secrets. Now, I wouldn't recommend that you use local secrets for production, but it's good for development. Local secrets just keep your files inside of a JSON file on your machine where you could use it as a key value store. So it's definitely not the most secure option. But if you stick around for the rest of DaprCon, my teammate Jessica Dean has a really awesome session that's going to show you how you could production harden some of your Dapper configurations. Let's head back to our web browser really quickly and see how Dapper uses some of these components. So if I head over to Zipkin, and I have this one exposed on port 9411, I can click on dependencies. I can hit the search button. And now I get this really interesting trace about the different services that are inside of my architecture and also what's communicating with what. So if you look here, you notice that the website is communicating a lot with the product API, but it's also communicating with the checkout processor, just not as often. If you wanted to search for any traces or spans, you could easily do so inside of Find a Trace section inside of Zipkin. All you have to do is enter your query and then go ahead and execute it. Now let's head back over to Visual Studio Code. The last bit I want to show you is how you could quickly debug these applications inside of Visual Studio Code. If you open up the .vs code folder, you'll notice that there are launch settings.json and tasks.json. And inside of these have configurations that allow you to debug into a container. So why don't we go ahead and do that? So let's go and set a breakpoint right here inside of our checkout order. And now I'm going to hit the run and debug section. And notice I'm going to select the Docker checkout processor attach, right? So I want to attach to that running container inside of my Docker Compose group. So I'm going to select the Composer group. And now I have to select what container I want. So here I'm going to select the checkout processor. Notice at the bottom now, it's asking, attaching to a container requires the .NET Core debugger in the container. Do you want to copy it? Sure. Why not? YOLO. Now the debugger should be successfully attached. Let's head back to the browser really quickly. Go back to our project. I'm going to submit a checkout really quickly. And in a few seconds, there we go. Notice that I've hit the breakpoint. And I have full debugging capability right here inside of Visual Studio. So notice I have my local variables. I have the debug console available to me. I could step through, step over, and inspect values inside of the editor. Now let's head back over to the slides. Now before you say anything, I know, I get it. That was a lot. We covered so many different topics and concepts in such a short period of time in that last demo, but my goal there was to show you how amazing Dapper could be for microservice development. By just adding a few lines and a few files of YAML configuration, you could see how we enable tracing and metrics and pub/sub and tons of these other building blocks that we could use. Also, I think being able to spin up that entire environment locally and then debug into a running container using Docker Compose and Visual Studio Code is really cool. So definitely had to show you that. Now, if you're interested in learning a little bit more about Dapper, and I hope that you are, definitely recommend that you head over to dapr.io. Make sure you check out the documentation and go through the Getting Started guide to see what it actually feels like to get into Dapper. We also have communities across a lot of different platforms. So if you're into Discord, make sure you check out our Discord channel where a lot of folks are sharing tips and tricks and projects and blog posts and all the cool things that they're building and doing with Dapper. There's a YouTube channel where there's regularly scheduled community calls with the team that give you updates about what's going on with the future of the project. Also, the team is on GitHub. Dapper is open source, so you can see all of the different components. You can see all the check-ins. You could read the code. You can contribute and submit issues. So I think that's a really great place for you to get plugged into what's happening. And if you're a .NET developer like I am, I definitely recommend that you check out the Dapper for .NET ebook. This is a freely available ebook. You don't have to put in your email address to download it. You can even read it online if you wanted to. But I think this is a great way for you to get started with Dapper. And even if you're not a .NET developer, it gives you a really good overview about how you could start putting applications together using Dapper. Now, I hope this session has been great for you. I hope you enjoyed it. Please enjoy the rest of DaprCon. I wish I could be there with you all in person, but until we are again, please take care, and I'll see you all soon.